Hello and welcome to this CodeBuddies.org live code hangout. By joining or scheduling a hangout, you can ask questions, work through tutorials, share ideas, or pair program on open source projects. Today we're going to be continuing working on the Sustainable Urban Design project, doing some data analysis on OpenStreetMap data, kind of looking around how the data are structured, and what use we can make of them to basically calculate livability of various cities. This is a live code session, not a tutorial. All the code is on GitHub, so if you're interested in following the patterns we uncover here, the first place you should check is the GitHub repo. It'll have the latest code at any given time. I typically try to summarize our work at the end of the video, at the end of the session. But until then, I don't really quite know how things will shape up. That's why I say it's not a tutorial. So what we basically do here is have an idea we're trying to achieve and work things out while chatting with people on Twitch TV. That's about it. It's kind of a social stream, social live stream. So it looks like we're good to go. The live stream is up. So if you want to try the code at home, you can clone this project. We're currently working in this experiments folder in a branch. I've got a pull request in progress. We're doing what's called proximity analysis. It's a fancy way of saying how close you are to things you need or how close things are together. And in the context of urban or sustainable urban design or livability, it's important that people are close to critical services, in particular, food, groceries, transportation, healthcare, schools, playgrounds, parks, open areas. There's a lot of cool things and services that cities provide, but those aren't necessarily equally distributed around the urban environment. And so by doing proximity analysis, we can find neighborhoods that have proximity to most of the needs and then neighborhoods that don't, and make that visible in a map, like color-coded red or green. And that insight can allow an urban planner or an urban designer to design an intervention, like a change in that neighborhood that would improve that situation. So what we need to do is figure out underneath the surface how the technical parts work, how the data are structured, how the algorithms work, so we can pre-process that information and surface it up to the layer of designers, where the designers are working. They don't want to think at a low level of the data architecture and algorithms. That just slows down their thought process, and it's sometimes alien to many people. It's not their forte. That's software engineers do that. So that's what we're working through here. So this code may or may not have been merged by the time you're watching this video. But in any case, I'll just put the link on the chat as well. Get that started, and we're going to go over to the code. And I've got a sustainable app. We're in the experiments directory. And the experiment is called notebooks. It's basically, I'm realizing a lot of these, a lot of the work we're going to be doing is going to be in notebook, a Jupyter notebook first, so we can move rapidly, and then we'll port it over to Python code that can be used in the Django app. So if we look at the structure of this directory, it's essentially a poetry project, so I can say poetry. And there should be instructions in the README. I need to update that. I was using Conda for a while out of necessity. But then I got rid of a dependency that was difficult to install through just pip or poetry, specifically the geodata abstraction library. And by simplifying our dependencies, I kind of stepped away from needing Conda. I think in the near future, I'm going to start working in a Dockerized project, so that these more heavy dependencies can be installed in the Docker environment, and that'll make it easy for other developers to get the environment set up, and then we can start relying on the GDL project, Geodata Abstraction Library, and other C++ libraries or having Postgres and things like that, because that's going to be really useful. Especially Postgres, it's got very great spatial querying and other computational algorithms like buffering, and essentially you can do set theoretical things like containment or intersection, which we're right now doing in Python. And I believe that if we did those in Postgres, they would be a little bit more optimized, and I could express those with the SQL language, which I'm a big fan of increasingly. All right, so I'll update the installation instructions, but essentially what we want to do is activate Poetry with Poetry shell, which we've done. And once we're inside of Poetry shell, you can see here where the environment has changed. I can run JupyterLab. So that'll be our project. We can check the progress we've made so far. Just copy this link and paste it. It opens in my default browser, which is off screen. There we go. All right, at this point, I don't need this shell anymore. I was just kind of showing how we get this up and running. Most of what I do now can be done through JupyterLab. It's increasingly like an integrated development environment, especially with extensions like this Git plugin. And at some point recently, I don't know when, but JupyterLab now has a built-in extension manager through the user interface. Previously, and to some extent still, you have to install JupyterLab plugins in the command line. There's a couple of those that you still do, like this JupyterLab Git plugin. I had to go to the command line to get that one working, but this table of contents one, for example, I just clicked install, the install button on the ones that, and it just worked. This GeoJSON extension might be cool. We are working with some GeoJSON data here, so I could demo that. Part of the purpose of this whole live stream series is just so people can get an idea of what it is, what's involved in being a developer, and we can explore things together. So, you know, it's an ask me anything type environment. There's no right or bad questions, and I'm learning just the same. I'm learning every day, so no shame in the game. So essentially, it's installing the plugin, I guess, in the local environment, and then it's going to rebuild it, because a lot of these plugins actually run in the browser. They're JavaScript, even though JupyterLab, I think it's primarily Python. I may be wrong there. Let me get some tea while we're waiting on that. So these plugins just make your life a little bit easier as a developer. And in any case, JupyterLab has some really nice built-in functionality, like being able to, it's going to have me reload, you know, inspect the functions that you're using, showing you the documentation in line, auto-completing things. I mean, it's really nice to work with. I enjoy it. And I know that not everybody's a fan of the notebook environment, but I believe there's a lot of good coming out of this initiative. All right, so essentially, just to catch up with where we're at and then figure out where to go from here. We've got some food sources and building footprints. These are, it's OpenStreetMap data around the city of Tampere. I just clipped a rectangle so we wouldn't have a huge data set to work with. And working with a couple of formats, but this is cool. This geopandas plugin has a function called read file, and all I have to do is pass it a file name, like the path, and it does everything for us. So it figures out the file type, loads it into a structured data, looks at all the data types, and just to show a little bit of the data. So here it is now in a geodata frame. And if we just take a little look, you know, it's already figured out feature ID here is an integer, OpenStreetMap ID could be an integer or an object. I guess these are large string-like things. The codes are integers. Feature class and name, those are objects or strings. And then the geometry column, it figured out, is actually it's called a well-known text geometry. I believe it was passed in as a WKT. In any case, so it figures out the data types and all that good stuff. And then we have a lot of useful functions. So what we're going to do is, currently there's a couple of indexes. We're just going to use this OpenStreetMap identifier code, because each feature in the OpenStreetMap data should be unique. It should have a unique identifier. And so by using that identifier and just double checking that there's no redundancy with this verify integrity, it makes it easier for us to do some stuff down the line. So now if I just actually, by way of example, so there's 16,000 building footprints in our data set. And now you can just see, since I switched the index and moved this head function down here to another row, we can see the index now here. And in a moment you'll see how I will be splitting out a column here. So one really nice thing about pandas and geopandas by extension is you can do operations on entire, like what we would call a column in common language, or what's called a series or an array. So this geometry column, there's a property here, I think it's a method, but it's in any case called centroid, and what it does is gives us these geometries can have arbitrary shape, and they're like buildings, outline of a building. And the centroid is essentially the best, average of those shapes. They're not all simple rectangles, but and so what we want to do is grab all those centroids and we're going to use those. We're going to do a geoquery. We're going to look for the centroids of the buildings that are within another geometry. But you can see here, when I look at this, this is called a geoseries. So it still has the OpenStreetMap ID. That's the key point. That's why we separated it out. So that index will come along. Then what we're going to do, so that's looking at the buildings. And I'll leave this generic. We're going to create buffers around several geometries. But for now, we just have food sources. So the map units, if you notice these coordinates, they're probably not very familiar. They're not latitude and longitude. They're in a different coordinate system. This coordinate system allows us to work in meters, which latitude and longitude don't let you work easily in meters. And you can convert that to imperial units if you need, but for the most part, just stick with metric and make things a lot easier. So all we're doing is just, we have a bunch of food sources around town. And this is a little bit abstract right now because we haven't shown it on a map. And for each of those food sources, we're going to kind of draw a sphere of walkability, meaning like how far would people walk to get groceries here? In Tampere, people, including myself, a lot of people walk to get groceries. It makes more sense because it almost would take longer to get in your car and find parking and then go and pay for parking and then go shopping than just to walk there and back, and it would save you a little bit of money. But that's only true up to a certain extent. So we took all those food sources and drew this 1 kilometer radius. We can change this parameter. And so now we were able to take those kilometer radiuses, and when they overlap, just kind of merge those into one shape. So we have a big blob of more or less the downtown area. And so we called it a union. Really, this could just be called food source catchment. To be easier to understand, let me just make sure we're actually running these cells. Yes. So I renamed it in the wrong place. Really quick. I'll just name it up here. All right. food sources catchment is okay. So this is, once we're working with geopandas, we have these really nice semantics. So the building centroids is a geo series, I believe. Yes? And the geo series has this operator that you can look for when those, each of them for each is within another geometry or data frame. Now this is a big process. There's a lot going on behind the scenes, so it takes a while. It takes about 9 seconds. So we've got 16,000 building centroids. That's just the dot in the middle. And for each of those, we're looking to see if it's within this kind of complex multi-geometry, because not all these geometries overlap. So there's several. It's got to check each of those, and they're not simple. So when there's ways to optimize these queries we might come to later. But there's always, you just got to decide how accurate you want it to be, how fast you need it to be, how much you're trying to save your computing time and resources, stuff like that. Nothing is perfect. There's trade-offs all the way. But what that gives us is essentially, it's a big list or an array of whether or not each of those OpenStreetMap buildings is within, the centroid is within that catchment. Now this is just a true-false. It's called a mask, because you typically will do something with this, and oftentimes it's used to make a selection, kind of like in Photoshop you have masks that you can overlay certain content. You can say show only these inside this triangle here or something like that, and everything else is masked away. So we're not using necessarily a mask, but what we're actually doing is just joining it back onto the buildings. And there's probably a way I could have just done that in place. You can apply a function that takes this series. I could probably apply this right up. Actually, let me just see if I can clean this up a little bit. So essentially what we're after, buildings within food catchment. We want this new column. So I think if I bring this up here. I think that this would work the same. Essentially, it's going to apply that and pop it directly onto the buildings table without me having to do this join method. You know, sometimes less code is easier to grok, and as long as this worked, I mean, so now I can just run this buildings head, and it has this new column. So essentially, this was made redundant, which is nice. So I didn't have to join it because I did it in place more or less. All right. So reading through this and reviewing the code is a good opportunity to clean it up. But this is the fun part. Now we get to actually take a look at it. And it's a lot of data, and these are complex shapes, and so it took a while to render it. But you can see more or less the buildings in purple. They have their food needs met within a convenient distance. And these aren't all houses, these are just buildings. Whereas the ones in red, they're going to have to consider probably driving or a food delivery service or something like that. And so as an urban designer, if I have a goal of reducing the people's reliance on cars, I might say, well, this neighborhood, can we put a neighborhood center, like a walking destination that could have a few shops, a commercial district, a small commercial district. This, just by way of knowledge, this is a really big commercial district. Most of these are like huge shopping, I don't know if department stores is the right word, but it's not quite a mall. In any case, these are really big stores, like big box stores. Now, we don't have Walmart here, but you would have a Walmart or something like that, or a Costco in this neighborhood. We have what's called Prisma and some big electronic stores and things like that. These are mostly residential and mixed commercial, mixed use zoning. And there's some industrial down here near the railway. I think this is a lot of, this is probably a commercial zone too, which will be another aspect we'll be adding to this. And the key is that each of these kind of layers can be joined together, and if you have a layer that has the zoning information, then you could use that to further refine this and say, show me the buildings that are residential or primarily residential, have some mixed-use residential zoning at least, and show me those that aren't within radius, convenient food distance. That's going to be the challenge, to figure that out. Let's go ahead and get this into an interactive map just so we can make sure the code below works, and I'll commit this. So the geodata frame has a plot method, and it makes a static plot, but sometimes you want to be able to interact with it and zoom in and out. So that's where JavaScript comes into play. That's why this stream is, geoprocessing with Python and JavaScript. Now, different mapping libraries need the data to be in different coordinate systems. As I mentioned earlier, we're using a coordinate system that makes it easy to do things in meters. That reason that was critical is we wanted these buffers to be measured in meters, something that makes sense to people. We're going to put it into a mapping library that uses latitude and longitude coordinate system. So we just need to kind of convert those. It's called a coordinate reference system, and luckily the geodata frame has a built-in method to convert coordinate reference systems, because GeoPandas builds on several mature Python spatial libraries. This has been one of my really joys of working with Python language, is how I think there's an ethos in the Python ecosystem of integration and extending and building up and out, like keeping things around, keeping things alive. To a certain extent, there is some fragmentation and duplication, but it's not rampant. Okay, so what do we have? We have food sources have been converted and buildings. Now, this I've changed. We actually don't need, let me just double check what we're going to plot, and I'll clean it up if I haven't already. But I did rename this to food sources catchment. So down here, I just need to say food sources catchment 4326. It's a little bit verbose. I can rename this in place, but essentially what we're doing here is this geodata frame to CRS method basically does this internally. We create what's called a map projection. It's like shining a flashlight on your hand, a projection from like three-dimensional space onto a wall of a different dimension at certain angles and such like that. That's what's happening with map projections. Just in a lot of cases, I believe that flashlight is in like the center of the earth and it projects it outward or something like that. I don't know. There's actually, it's a little bit mind-boggling. There's a lot of literature and analogies, but in different, some of them project onto a cylindrical. So you have a light source in the center of the earth and a cylinder around it, and it kind of projects in every direction isometrically. But I think that would somehow miss the poles. I don't know. In any case, all we need to know here is that what projection our data are in and where we need it to go, and that unto itself is pretty esoteric. We can ignore these warnings, just some deprecation warnings from internal library, future warnings. Although it looks pretty scary, it's not. So now we have the data. I need to make sure when I call this later. This is just a little bit of footwork I needed to do. Essentially what we're trying to do now is get them into a format that the mapping library can work with. So first we need to get in the right coordinate system, and then we need it in the right data format. This mapping library doesn't work with geodata frames out of the box. I think there is one in the Python world that would make that simpler. I'll look in it just a second, but I just want to make this code work and commit this. So we just take those data frames that I've converted the coordinates and same as a JSON variable here. I could pass this directly into the map, but I like to do things one step at a time. And here we had it, this is a geoseries, it's not a data frame. So I had to convert it to a geoseries. To a data frame. It's weird, but a series is just like a one-dimensional array, and a data frame is the higher level abstraction that has a bunch of series, and it has the method to JSON. This geoseries doesn't have the method, but the data frame does. So in any case, these are the kind of things you uncover when you're coding along the way. So here we go. And we're just going to check now. This was my kind of double checking that this was going to come out as a data frame. So I know it does, so I'll clean that up. And now what we do is, I mentioned the mapping library likes latitude and longitude. So we just want to specify a center coordinate. And I know that our data are centered around the city of Tampere. So these are the latitude and longitude coordinates there. And I just create them as a list. And then we're using Folium. And I'm just remembering something, suspenders is the name of this other Python library. We'll look at pandas. It was for data visualization, not mapping. So now we're going to add it to the map. So we have this map instance. It doesn't have any data there. The Folium library does give us some helper functions for working with GeoJSON and a couple of other data formats. And it just needs the data source and a name for the layer to display in the legend. And we're going to add it to map all in one line. So there's three sources: the food sources, the food sources catchment, and the buildings. And it basically adds them in the layer you mentioned here. I think if you're wanting one to show over the other, we want these building footprints to be on the bottom, so we did it last. I'll double check that. But in case now we're just going to show the map. Here's the important part. It takes a while to render it out, and by default the zoom out level is kind of far, but we've got a map centered on Tampere. Several layers, the buildings at the bottom. Let's zoom in a little bit without, I should set that anyway. So you can kind of see how rectangular it is. I just clipped a bunch of the data to make it more tractable, and that way I can make mistakes faster. Because that make more, at least when I'm programming, make more mistakes than I have successes, but that's just part of my process. I think it's kind of common. Unless you're just in a flow of doing something that you've done 100 times, you'll still be making different mistakes. All right, so let's just hide a couple of these maps. Now that we're here, let's take a look at what we got going on here. So first we started out with these food sources. These are all the ones in OpenStreetMap that are identified as supermarkets or convenience stores. Not every convenience store I would consider a food source. Some convenience stores have just stuff like soda and candy in the newspapers and stuff. But a lot of the convenience stores in Finland do have some produce, and I don't know of a way to further refine that query. So that's just another aspect of this that's not, that's less than perfect. All right, so we took all those food sources and we created the catchments. So those are those geometries we were looking at earlier. Here they are on a map. And you can see most of the downtown area was pretty well covered. Now, here are the building footprints in the map. There's a lot of them. And as you probably noticed, when I click this button, it takes a few seconds. So it's just, there's so much data and the geometries are so complicated, it takes a while to load. And if I zoomed now, and now it respawned. I'll zoom again now. I'll zoom now. There's just a little bit of lag. It's kind of not the best, probably user experience, and I can actually profile it. So we'll record and we'll zoom now. Zooming. And we'll stop and take a look at that profile. And you can just see the browser gets really busy. And if we were working on a larger data set like all of Tampere or something, even a big city like New York, which an area like this in New York would have a lot more geometry. We have these big lakes that don't have much geometry there. But if you look at like Chicago or New York downtown, you're gonna have really densely packed stuff in an area this size. This is a few kilometers across. But yeah, so basically when I zoom, there's just a big spike of activity, and then it paints. You can see the paint now after it's done all this processing. So it's got to get the DOM process. DOM is not slow. DOM is not our enemy. I'm not one of those people. But it would be pretty cool to to have an interactive map that maybe showed those building centroids and color-coded those. And a bunch of dots, like 16,000 dots, is much probably easier for this thing to render than 16,000 building footprints with points and lines. Like, I used to live here. Oh, and here's our library. Check out our library. It's crazy looking at it. It's cool though. It's a nice library. But that's that's literally the footprint. I don't have an aerial view of it. But it's quite unique architecture. So yeah, let's go ahead and save this and give that a try. Just get all these centroids in there and color code them by this attribute. That would be a good learning process. Now that we've done a spin through the code. For 1 second, let me just check my messages. Got a kind of little bit of a sort of crisis at work is apparently the word for that. Oh. Yo, all right. Okay, so here's a nice thing. Jupyter, I think it was an extension, but this Jupyter Git integration is pretty cool. One of the problems with notebooks is that the data format that it stores in, it's really got some binary blobs in there. Like this map, for example, gets saved in the notebook, and the output of various functions like graphical output gets saved as a snapshot with the notebook too. That makes it easy to render it. When you first load the notebook, it has the last results and you can go through and just read it without having to run everything again. So that's the reason behind that. The problem that was identified is that it makes it difficult when you're in a like a revision control system like Git that's primarily geared around working with text. It makes it really difficult to review with all that binary blobs in there. But in any case, it was just a challenge to be overcome, and the built-in Git integration handles it really elegantly. It lets me diff the changes to the notebook side by side. And essentially, I'm just reading through these to make sure there's not any major stuff. So I've removed some cells because I sped the code up a little bit. I applied it directly to the code didn't speed up literally. It's still taking along around 10 seconds, but in any case, I removed a few lines for legibility, readability. Yeah, but mostly the thing's the same. A couple of cleanups. This map. All right, cool. Yeah, clean up a bit. Now, oops. And it lets you commit right in line. Tells you what branch you're on, what repository you're in. Lets you look at the history. This is all right in JupyterLab. This is, I haven't used it in a couple of months, I suppose, so I'm very surprised. And also, I haven't used this Git plugin, but in any case, I can push it directly there. And Okay, so this, it needs me to put in my password. It's actually gonna, I'll have to do off stream real quick, but strange. All right, I'll be right back. All right, cool. Now that it's got my my key in memory, it won't ask that again. Yeah, so we have all these dots, and it's actually a column. Let me just see if there's already a library that'll take a geopandas to interactive JavaScript. Bokeh. I say that bokeh or bokeh? Bokeh. I can't remember. It's that. It's bokeh. All right, so this does give us interactive plots. I like this, the bokeh project, and it's Helsinki data. This is the second time I've come to this University of Helsinki automated AutoGIS project. Bokeh is part of a really cool initiative in the data science community called NumFocus. All of their NumFocus projects, I just think, are in good company and really useful. It's a nonprofit organization. There are some other really good plotting libraries in data visualization community, like Plotly. And I've used those in the past. Bokeh is kind of a competitor to Plotly in some ways. But again, I just think that the umbrella of projects that NumFocus are sponsoring, there's some really cool stuff here. And it's not all Python, it's many different languages. That's another thing I've noticed, that the data science community is kind of able to converge and get beyond sort of infighting around languages. In fact, this Jupyter project, the name comes from Julia, Python, LaTeX, and R. That means it kind of, you can run all of those languages even in the same notebook, I think, and Bash scripts with, you just use these cell magic to say this is a shell script. Or you can have a different kernel for some notebooks, having like a Julia kernel or a Python kernel. In any case, yeah, I'm in Python land. There's things for astronomy and economics, quantitative analysis for quantitative economics, data visualization. Conda Forge is a community initiative around the Anaconda project, which is a driven by a corporation, and in a way kind of forked the Python packaging ecosystem, I think, for some pragmatic reasons. Dask is for distributed parallel processing. I don't know. There's a lot of these things I have no idea what they're used for. PyMC, I think, is for like Bayesian probabilistic programming. And here's Project Jupyter. So in any case, let's go ahead and give Bokeh a try. Anyway, wish I knew how to pronounce it there. And see how we work with geographic data. And specifically how I get a base map in there from OpenStreetMap. Because it's mainly just, it's plotting stuff. It's a plotting library. It's not necessarily thinking of these in geographic terms. So it's happy to show anything on any coordinate system apparently, but whereas the current library, this Folium, is using is specifically using Leaflet.js, which is a JavaScript mapping library. Let's see if this has got tile providers for OSM. Yeah, we do have a tile provider here. And this is the main thing. This coordinate system we're working with is it's called Mercator program. Mercator, how do you pronounce that? A coordinate system, specifically promoted by Google for their Google Maps. It's also used by Folium. The OpenStreetMap data are not in, or they're in the Web Mercator, the Web Mercator projection. But the Folium is using lawns. So actually, this bokeh library would make it a little easier for us to work with the data directly. It's already, without having to reproject it. Maybe. That's fine. Out. So I don't want to use Google Maps. I don't want to have to deal with the key. All right, so tile provider. All right, CartoDB Positron. So maybe there's an OpenStreetMap provider. It's closed. That's potentially good. This is one from GeoViews. Think about these are just some other really nice plotting libraries. This HoloViews, I believe, is also part of NumFocus. This is using bokeh. We may turn to this. Let's not get too far off. Nice. Okay, so we can just put in a tile provider OSM. All right, so let's go ahead and we'll grab a bokeh. To do that, we need to hop back to the shell. Make sure our changes are saved. I haven't done anything really. Stop the kernel. If this works, then I don't think we need a Folium anymore. JupyterLab. Refresh it. Should have our token still. Good to go. So I'm not going to drop Folium yet. And we're not going to switch to HoloViews. I'm going to follow this bokeh plotting. And let's take a look specifically at bokeh tile providers. We've got Esri imagery. OSM is what we're after. Wikimedia, Stamen. Okay, these are really nice. The Stamen base maps are very pretty. The Stamen toner is a cool one because it's detailed, but it's grayscale, so it gets out of the way. If you got colorful data and you don't want the base map to interfere with the interpretation of the data, this actually might be a good one. We definitely want Git provider, and maybe we want Stamen. I like OSM. I don't know if it's just going to use the standard OSM. Stamen, all of these use the OSM data, and they just apply different themes to it. Let's go with that. What else do we need here? I'm going to close this because this is interesting. So I want it to render it inline. I'll have to figure that one out. So I don't really want it to render to an output file. And frankly, I'd like to not have to specify the bounds. If possible, it would be nice that it infer the bounds, or so this might be useful. All right, let me just think about this for a minute. I'll be right back. So there's kind of two parallel things I want to try. One is getting this bokeh running, but I could also see what I can do in Folium to change at least the, whoops. So that delay, it makes it confusing, but to change the color or the style of these polygons based on that property of whether or not they're within a reasonable walking distance, whether or not they're inside of that food catchment. In any case, though, I know I can't be working with full polygons here. And I think basically Folium automatically looks for a geometry column. So it's doing that behind the scenes, and essentially if I change the geometry column here from being this multi-polygon, which is the actual building footprint, to these building centroids, which I also can store in the building's geodata frame. It's already a property of the geodata frame, it's just not a column, and it's certainly not the geometry column. Doing that alone might make this chart a little bit more performant and would be useful for bokeh because we're going in that direction too. So let's stick with what we've got so far. We'll come back and see if we want to use bokeh. We've got it in our environment. Let's go way up here to when I got these building centroids. Now really, centroid is a property of the geometry column. If I want to make it a property of the buildings table, I would do something like this. Make a new column, centroid, and just kind of, first let me make sure spelling things right. Oh yeah, because I've restarted the notebook. All right, so we have a geometry column here. We will then have a centroid column, which is a point always. And then if I want to swap the centroids to be the geometry, without losing the geometry. Let's try that set geometry, but I don't want to lose this original one. Let's see what happens though, and I can revert it. There's a bunch of helper methods. Oops. do in place. Now we still have this, literally the geometry column titled geometry, that is, with multi-polygon data in there, but internally, I guess, for whatever reason, this, however it's representing it, the centroid is the geometry column. Well, let's go ahead and spin through the notebook. These all are working. I think this now should work this way. Because the geometry column, and that was fat. Oh no, it's not done. It should take 9 seconds. A little bit faster. I don't know specifically if that's because I've changed it. In any case, I've got the new column. The centroid is a geometry column. I'm just thinking when I drop it to GeoJSON, if it's going to know the geometry column, if it's going to use the correct geometry column, but already this is making it pretty fast to plot, easier to interpret, and relatively speaking. You can see these blobs at least. I could even take what's called the, what is that called? Convex hull of these to get the shape roughly. So you can kind of just say this geometry and this geometry have good coverage. This one doesn't. It's quite interesting. The patterns you can start to see. We still need to project the coordinate system to get it into the web map. Now here's what I'm interested in. If this toJSON method will still, let's see, work. It doesn't work, that's all right. Now when this, what it's trying to do is take this column called geometry and serialize it. And what if I just drop that column? But the way it's represented, for some reason, can't be converted to a string in JSON unless I convert it to a string in advance. This is lossy. It's just a matter of pandas defaulting to using rows. Instead of columns. There we go. Now I just dropped the column. For the purpose of exporting to GeoJSON, it might still be present in the original buildings. So if we look at buildings now, yeah, so it wasn't lossy in the fact our original data frame still has the column, but the GeoJSON doesn't have it, so that's all right. So here's what I was kind of guessing. It says you were passing non-geometry data to the GeoSeries constructor. So it doesn't realize, it literally wants, it's relying on having a geometry column to designate that this is geometry. The name is important here. Even though geopandas internally is using the centroid as its geometry column, we would have to change the name. Okay. In doing so, hopefully this would be cast to a string. Yeah, so what I'm guessing is that since there's no geometry column, the map is going to have a difficult time that layer, the buildings layer. Even the catchment is not rendering. I don't want this to turn out too kludgy, but we're going to just rename. Should be .rename in place is true. All right, it's going to let us do multiple columns at once. Footprint. So we want to rename the geometry column to footprint, the centroid column to geometry. And we want to do that in place. And that should work. So let's take a look. No. Dang it. That's why. So this mapper was applying on the wrong axis. So let's go ahead and bring this here. So if I tell it specifically, these are the columns. See, these are kind of like IDE features that are getting, in the Jupyter text editor now. There we go. We've swapped them. Let me just double check. So let's see if it still maintain this. Centroid as the geometry column, which is now called geometry. It's so kind of confusing, I understand. Sometimes that happens. And plot. I just got to do these calculations first. Good. All right, so the calculations are still, 9.5 seconds. Now I think when we export it to GeoJSON, we should be good. Reproject. And this one we actually don't want to drop anymore. The problem here is this multi-polygon object is too complicated for JSON to handle it. Because it's still, still a geometry column. Well, we don't need to serialize it for the purpose of getting into the map. So I can kind of skirt this issue again by dropping it, by dropping the footprint column. Sometimes I'm wondering, if this is all just important or what, if I'm getting off trail. Let's see if it thinks there's two geometry columns or what it wants to do. Other columns would contain multiple geometry columns. Yeah, if we check these D types again. Got two geometry columns. not sure if this isn't really a good idea, but. Geometry column, everything else should work. Plotting it. This is, I believe, going to be a derived table. The OpenStreetMap data will be unmodified in its own table in a Postgres database. This is kind of what I'm thinking in the back of my mind. So any derived information does not need to duplicate the original data. So that might be a good justification for dropping those footprints. However, though, if we want to style the footprints based on properties, we'll have to just join them in a query. So that would be okay. All right, so we got a food catchment, we got the geometry column, and here, and the GeoJSON didn't complain. It's taking a while though. There we go. Slower than with the building footprints. Weird. They have toner here. All right, let's see. Is it still? Try to save it real quick so we don't lose those changes unless we've already lost them. This is cool. Okay, so we don't have to hop through the coordinate. All right, don't have to do the coordinate conversion process. That is nice. All right, I wish I would have known that before. Not a big deal. It's all learning process. Zoom start, maybe 7. Oh, dang it. Oh, I've got a multi-cursor. That's another interesting thing that's available. So, 7. Would it be higher or lower? Can delete that whole section. All right, where are we at? I don't know if there's a keyboard shortcut for commenting, but I guess. All right, so we need a higher zoom mic. Double check. 13. Ah, the data are not there. Damn it. They're there. 3857. Oh, I see what I'm doing wrong. One thing is I'm centering the map using lat long, so that's not going to work. See if this works. Well, let's just change the projection, but a coordinate system. Yeah, so anyways, we just need to reproject the data. No, that's actually did the wrong thing. I wanted to delete this and uncomment that and not change the CRS anymore. All right, we've got food sources. The default pin is so obtrusive. Oh, right. Too many moving parts. Let's see if we can get some good progress here and color code these points in the folium map, which is interactive unless people zoom in and out. crap. Like the whole browser gets so slowed down. It's still thinking, I guess. There we go. All the layers. Wow. Oh, that's why, because for each point, Folium's trying to render the default map marker, and it's just bogging the bogging down the browser. All right, so we have to fix that. Oh boy, let's close the tab. Curiosity, can you do blending modes with overlay layers? Opacity. So one of these layers might take an argument out of the style function. Might return just a circle, a point. So it's just a dictionary, which basically that. So where are we at? The data are all there. Yeah, well, this is another example of why do you use smaller subsets of data first. So essentially what I need to do is just slice this down to like 3 buildings. I'm trying to put the whole cake in there, and I just need one slice at first. Rendering this out to a raster graphic works fast and fine, but trying to get it into an interactive map, it's been problematic. This might be where we need to actually fork off and go in an entirely different direction. I think there's a lot of potential here that it's not explored in pursuit of this interactive map. All right, so now when we convert it to JSON, let's go ahead and just, what do we want? The buildings. Let's just take like the first 10 of them, slice that down. Just to see if our point style is working. Okay. And it's not working, so that's still going to be a problematic. Yeah, so we can't render 10,000 or 16,000 of these in the browser. That breaks things. So let me make sure, did I apply the style layer to the right layer? I might not have even applied the style. That's the problem. So I went ahead and defined the style function, didn't apply it. And I don't think I need to invoke it. Help is English. Trying to show circles instead of markers. Yes. Yes. On each feature of the GeoJSON. This is a Folium library which mirrors the, to some extent it follows the Leaflet API. But it doesn't have an, this GeoJSON function doesn't have that on each. Is 0 positional arguments, but 1 was given. All right, so I'm just going to read the Folium docs style function. The weird thing is, so it must be passing in the point as x. So even though I'm not using it in the function, it's going to pass it in there. So let's just call it feature. I don't have to do anything with the feature, but that'll at least let us get through that. Oh, man. They couldn't have made it a simpler function or anyway. I mean, it just should return this dictionary, right? Yeah, so with the leaflet, you specifically say it's a circle marker. And here's where you mentioned the on each feature. All right, so this is where I'm kind of just starting to question whether or not I really, again, want to keep going down this path with leaflet in general. Let's see if there's just an example. All right. So I'll need to import this. We're using Folium here though. And the entry I got is JavaScript. So this maybe it would work. Okay, let's try it. Yes, so about syntax. What do they basically need? They create a circle marker. Mm-hmm. It's pretty big notebook. Maybe Canvas would also be faster in general instead of working with the DOM, but I want to get it down to manageable. Something manageable enough for the DOM. The interesting thing here, though, is they're bypassing dropping it to JSON. They're working with a data frame directly. Except they're having a side effect here, so essentially their code's kind of messy. This is, wait. Yeah, they're adding it to the map inside of that function that's being applied against each row in the data frame. That's so okay for an example, but I don't think I would want to use that. Again, they're applying it and having a side effect in the map. You know, I'm just not crazy about leaflet to begin with. If I can just pass in the marker as an argument, I think that would be the most elegant way. But I don't want to put the arguments on the map one at a time. I mean the markers on the map one at a time. All right, well, the main goal of this notebook is to give me some server-side code. And the sort of stuff mapping was just to help me get an idea if it was working. But it's hard, I already know it's working. In fact, the leaflet's been almost more problem than it's sort of been worth in terms of having to convert the coordinate systems and difficult, you know, defaulting with this really big map marker and just difficulty. I don't know, each step of the way, it's not that great of an experience. So what can we salvage here? So with this base plot method, I'm not going to get a base map, which is okay for now. But that means I don't have to drop any columns just to make it fit the GeoJSON situation. So I like that. I'm just going to go ahead and take out all the folium stuff. I don't need to convert the coordinates to go into folium now until it's absolutely needed. I'll refer to the git history if I need that, if and when I need that. And we'll take folium out and I'll drop it from the project. See how far we can get with bokeh. Relatedly, the front end of this, we have a JavaScript client for this project. It's not using Leaflet for similar reasons. I tried with Leaflet because it's sort of seems the simpler way to get up and running, but well, I ended up going with open layers. I had troubles with open layers too, so neither of these is perfect. You know, Leaflet's really popular, so This should all still be good, and we got the footprint. Centroid. Let's just call this then. Actually, don't we need to rename that then? And probably don't need to do this. Two geometry columns, not losing data along the way. This is though interesting now that, let's see if this takes a lot longer. Okay, that's no geometry data set, expecting column geometry. All right, let's double check this here. Because I had to rename it to geometry column. Okay, okay. I might be able to specify that in the argument. No. All right. Let's commit this. English, do you work on some similar projects? Do you work with Leaflet? What's your experience been with that, with Leaflet? Alright, so we got some changes. Remove folium. And I'm not using bokeh yet. It'd be nice to actually compare the plotting time for both of these. It seems like just plotting the points would be faster, but I don't know until I've tried it. But in any case, I'm wondering, if I run, I don't want to get too complicated, but if I run a clustering algorithm on these points, and if I can find several clusters and then select the convex hull for the cluster, if I might simplify that, or if there's a better way of doing that in terms of what is that, contiguity, how like these, how contiguous these areas are that are served, have food in good proximity and don't. All right, so the other thing we were going to do is check another data source. So what do we have? Buildings, food sources. If I bring up QGIS and I save some bus locations of bus stops, we can continue the analysis there. I can merge this pull request and work on Dockerizing the project. Now, I've been at this for 2 hours now. It might be good just to get a stopping point. What would be the quickest stopping point right now? Well, we've actually started with bokeh. Here's, by the way, just for what it's worth, the project in QGIS. We're trying to replicate in this to a certain extent. Where basically we have transport stops and or bus stops more or less, and food sources. And we want to find buildings that are within a reasonable distance of both, so they can easily get to a bus stop and a food source. And we started by buffering 1 kilometer for food sources and joining that buffer, and then we made a 250 meter buffer around each bus stop. And then we essentially took those and applied we looked for the intersection or the union. The intersection of the two. And we ended up being able to select the building footprints that were in both sets, or intersected both sets at least, and the ones that didn't, and they're colored based on that. So we'd like to be able to get this sort of analysis when we're in Python land, instead of through the graphical user interface. So what I'll do is I'll export these bus stops while we're here. So geopackage. And then during another session, I will work on that. 3857. Oops, I didn't need to add it to the map. Okay. Actually, if I just close it without saving, it should be fine. So let's just take another look at this not folium, but this bokeh recipe. So we haven't done a folium, unfortunately. It didn't quite pan out. Geodata. So we've already done the JSON dumps part. We'll need this, bokeh models. I think we'll want to show. Let me double check a bokeh. Jupyter. All right, so we just need to import that. Still going to have some trouble serializing this, I think, but all right. Yeah, OpenLayers I've worked with a little bit more than Leaflet. They're both pretty solid though. And each of them has their trade-offs. I think OpenLayers is like a more full mapping geospatial sort of suite and more complicated by that nature. Whereas kind of Leaflet makes it real easy to get up and running, but I don't think it's quite sophisticated in the long run. Gotta strike the balance of like simple with finding that what's right for this project. Hopefully this, most of the data is just gonna be passed to a, right now we're using Mapbox.gl. By the way, you might check this out. It's really nice. The reason we started out with Mapbox.gl is for the idea that we're going to have three-dimensional data, at least like buildings with extrusions. Might not be like in the long run that will stick with Mapbox.gl, nor that the project needs 3D capabilities right now. It might just stay with two-dimensionals. But there's a really cool project called Kepler. I think it's called Kepler. This one's really cool. It actually just it's sort of an analytical toolbox. You can just load in some data and start playing with it right off the bat. So you don't have to like necessarily program a web mapping framework. This one will let you plug your data in and start exploring it. Even time series data is fun. So this is made through Uber, I think, made this originally and open sourced it. And maybe they're the main contributors or stewards right now. There's a Jupyter widget, actually. Oh, I didn't realize that. Wow. I should probably stick with this, in fact. The thing is, we're using Mapbox.gl. We're not using Kepler.gl right out of the box, but this is nice. Anyways, yeah, this is a highly experimental live coding series. You can probably tell by now. And what else was using this web.gl? This Mapbox.gl. Now I can't quite remember. Have a Mapbox.gl Jupyter, in fact. From a pandas data frame. Wow. Maybe actually we should be using this instead of bokeh just to keep things consistent, because the goal is to get this code into the front end. Yeah, hey, thanks for stopping by, Zanglish. Oh, I thought you were heading out. Yeah. If you got anything, I'm learning as I go too, so it's always neat to share knowledge. Yeah, our main front end we're doing is in JavaScript, so the target is going to be to get this stuff into JavaScript. I've just got to figure out some server-side processes to do the kind of spatial analysis and answer the questions at a high level of thought, like houses within proximity to grocery store level, not down in the weeds of all the geometries and stuff like that. But if you check out this source code, the platform is our Python backend where this code is hopefully going to land pretty soon. We've got a user experience, user interface experiment here. And you can see our dependencies. Quasar, Mapbox GL, and we're using Vue and Vue Mapbox. So yeah, this might be a good way to keep things consistent and familiar. You would basically get the data frame. We map it to GeoJSON. And here's where we want to circle viz points. We wouldn't do it without an access token. That was one of the things that the Mapbox does kind of steer you towards, having to do things with their APIs. They're also a service provider. Well, you can do things without an access token. It took me a while to figure that out. Everything's got gotchas, man. And here's what we're after, categorical points. I just don't want to use the access token. So all we had to do is essentially specify a different base layer to access tokens so you can stream their tiles. I'll show you one other thing. It's Apache eCharts is why another reason I went into the Mapbox GL part. It gives you a layer on top of that. And we were going to use Apache eCharts for the front end because not only do we have spatial data, but we'll have like time series, charts and things like that potentially. So eCharts is a more holistic and probably one of the most complete charting libraries I know of in JavaScript ecosystem. And I've tried several of them over the past 5 years. I've been doing quite a lot of JavaScript plotting. And everything's got trade-offs, but a lot of the libraries I've used, including like Chart.js, I can't think of a lot of the names off the top of my head right now, but they're really incomplete. They're just like inconsistent, incomplete. D3 is like a assembly language for building your own charts. HiCharts is commercial. AmCharts I never use. Google Charts is proprietary. ZingCharts, Fusion Charts is proprietary. CoolChart. NVD3 is the one I use a lot. It just is almost non-maintained anymore and very inconsistent. Every chart is conceived as its own like world. And what you're wanting is something that's holistically designed and consistent across chart types. Maybe all of the chart types have a similar prototype or primitive form. And the only ones I've really found that have that kind of both holisticness and completeness, breadth, I would say, have been like Plotly.js. This is a bunch of projects, so I wouldn't want to go into that unless you're plotting networks and or you want timelines that you need these specialized tools. This is a graph relating plotting. So Plotly.js, eCharts, pretty much the only two that I can kind of say have really would carry a project for years that would need multiple types of data visualizations, even geographic data visualization, Plotly.js. And the cool thing, Plotly actually has bindings for multiple programming languages. They were proprietary for a while, now they're open source. They even have, if you're doing like React stuff, they have language bindings for JavaScript frameworks. Really elegant. It's backed by a commercial entity. which means that their priorities will govern the evolution of the project exclusively, and they, I think, are pretty good about supporting it and promoting community contributions and things like that. But I believe, I'm not sure, I don't want to be too critical. eCharts is project of the Apache Software Foundation. It's just half the documentation is in Chinese because it was originally a product of Baidu, and they have donated it to the Apache Software Foundation. Anyways, for the WebGL stuff, it's using, specifically for the mapping, it's using Mapbox.gl. We've used several. I've got another project, open source project. We do data visualizations of well-being activities, and we've had some JavaScript churn in our plotting libraries in particular. All right, so let me just see how to do this without an access token. Yeah, we don't want our project to be, not only the project to be wed to the Mapbox access token, but even new developers having to get that. It's a barrier to entry. So I'd prefer to just do it without it. In our JavaScript front end, we were able to create these maps for the UI experiment without an access token. Page container. Let me just double check. It's been a while since I've been working on this code. Here it is, Mapbox.gl. And you can essentially render, you just have to specify the tile layer, and then you get around the whole access token thing. Yeah, it would be a good service. I would also, consider using Mapbox as a service provider. They do a lot for open source and for OpenStreetMap and things too. Yeah. So I think it was in our Slippy Map example where they do it without they changed the base layer here. Create a little tile server. I just hope this layer on top, this Mapbox.gl Python layer, allows us to just render these functions without an access token. How are they? I could try without an access token. I just need to figure out then how to specify the base map. Or I can go back to bokeh. There we go. Raster tile is an example. if we're passing the tiles URL, I hope that it would just work. One way to find out. So what will you do? Pip install it. Yeah, and for example, I'm hesitant right now to add any unnecessary frameworks or dependencies to the project. Let me make sure this is saved. Because we want to make it friendly for new devs, also simple for deployment and things like that. So right now I'm looking at adding Docker finally for a couple of components that I'm not going to be able to get around. Mapbox, right? How does it say to install it? I guess just. Well, it's a no-go anyway. All right, so back to the point, I guess, focusing this code on what the server would do and just glimpsing it, because it's an essential part of the problem is seeing what we're doing. And for that need, you know, even this, the plotting from the default geodata frame is fine. I just want a base map also. And Bokeh can support that. The kernel's still running. I think I don't need to run through all these again. All right, so I've got this. I should be able to show it in Jupyter. Let's go ahead and go back to the mapping geodata. So we want this. Tooltips might be useful at some point. Something smaller. Right. Why did that have to do? This is Kludgy. All right, so essentially I had to convert this GeoSeries to a GeoPandas data frame. I had to do that last time. I deleted all that code. Okay, now we're going to create a figure, so we'll call it plots. And an import figure. Okay. I should actually be... If I want to plot circles, then I should be using that really big. Oh, I can use a subset of it. Let's do that. So not all 16,000 of these, but just some of them. Let's just get like 10 of them. Okay, what did I do wrong? Same problem. I think if I just, where do I put the columns? I want to specify some columns here. I'll specify a list of them. I can't remember if this goes before or after the slicing. It goes before the slicing or after the slicing. I think it doesn't matter. Okay, what do we want? Geometry. And maybe name, if we want to do a label. No within food catchment. Let's try that. All right. So I've got a subset of data. Geosource. Plot's getting ready, and now I can style it with, I can actually run the circle, smaller circles. Do they have to set the bounds, or will it automatically set the bounds to the data? And this is nice. I really do like the, I think this should work, the data-oriented sort of plotting APIs where you just kind of specify in other words, you just specify the columns in axes you want to do certain things. Let's see what happens. Oh yeah. Show plot. All right, open in a new tab. We do indeed have points on a map, a slippy map. It's progress. However, Might have been I just didn't call the output notebook function. Again, all this seems like I'm getting off track. But there, all right. Maybe if I rerun that. That's in a strange error. Let's try this again. Strange. If I restart the kernel and run all cells. There it goes. Something in the memory that was still bound in memory to another plot that was being served. So I just had to restart the kernel. That happens a lot in Jupyter notebooks. Basically, when weird stuff happens, just reboot it, unplug it and plug it in. Power it down and power it back up. All right, cool. So we've got some points on a map in the notebook context. Let's save that. It's progress. Just going to diff that to see what exactly did change. Oh, now, okay, broke my diffs. Why does everything have to break something? All this is so I can get a Slippy map with a base layer. Please. What do we pick? Stamen? Stamen toner. We'll plot the... We're done here. Aha, you just add a tile layer. I don't know which... certainly can't do this before, though. I don't know which order I should do this stuff. Got a thingamabobber there, and the other order. All right, so create the plot, tile provider, then the circles, then show the plot, and the circles are on top of the base map with no color. All right. pretty good though. Ah, okay, it should be fill color. I thought this color would be the field name to classify it by, but I'm not using Seaborn. But this one will be easy enough, I think. All right, so I just pre-calculate the colors. Easy enough. That might have even been with the... No. Oh yeah, did they have a function here? Set the color there. We're getting a little bit fancy here. That'll be good. Our essentially, what do we want to color these by? Let me think here for a second. Buildings and their membership in the set, just like this. So essentially I can add a computed property or another field for plotting purposes. Let myself know what's going on. And what do we got here? Buildings, so I'm going to cast this row. Hey, what's up? Let's see, data oriented is, and you specify the whole data set, plot circle instead of an object oriented, whatever you loop through. Yeah, data oriented. Yeah, I'll show you, like, have you worked with Seaborn, or there's another, there's one in JavaScript, it's called, well, there's Vega, which is really good. High-level grammar of graphics. Now this is a whole nother level. Vega, I would like to be using this as well. I've just never taken the leap. There's something, it's all declarative, data-oriented stuff, very consistent across the types of plots. This is really cool. Concept, I've not been able to do it in practice, but in terms of back to your question about data-oriented, there's one in JavaScript called data-oriented plotting. It's not charts, not viz. I'll have to think about it. I've tried Dimple, didn't get far. It'll come to me, but the main thing, Seaborn comes straight to mind. It's just not interactive. It's like everything's got trade-offs. But if we look at a Seaborn plot, so you pass in, here you want to make a line plot, you pass in a data set, as you mentioned, and you tell it the X and Y axes, and for example, what dimension should be used to color the plot by. In this case, region is a column of data, and it looks at all the values of region and finds a way to color those categorical values as well as the event. So it kind of does all that for you in a declarative, more or less, through arguments. We could be using Seaborn for this. I don't think Seaborn's got geographic plotting capabilities. It may, but it's not interactive. So if I want a Slippy map, then Seaborn's not the way to go. That's what I mean by data-oriented. Yeah. I believe data-oriented plotting libraries, from my perspective, is like the pinnacle of what we can achieve in terms of usability, especially when they're consistent across plot types. So Seaborn, it's consistent, it's fairly holistic. I mean, the set of plots that come with Seaborn are comprehensive for most statistical data needs, hence the name. Statistical data visualization. It's an excellent library. But I think it's increasingly important that we present people interactive plots in web applications in particular so that they can actually zoom in and pan around and hover over stuff and get to know it a little bit better on their terms and not so much in a static JPEG view. So unfortunately, Seaborn's good for print publications and things like that, but when we're doing web apps, we need things that are interactive. Now, Vega and Vega Lite, and there's Python bindings for this as well. They do have interactive plots. Let's just take an example of one. But it isn't by default, maybe? I think you have to, if you want tooltips, you have to kind of specify that. Online editor. Oh, maybe that's just a JPEG of it. Let's go ahead. This cool online editor, though. Yeah, so it's not by default, it's not interactive. And Altair is the Python binding, by the way. Save an example gallery. In any case, I wish I could remember that name of that JavaScript plotting library that is data-oriented. They might not even use the phrase data-oriented, but it does. I do recall mentioning that on this site. It's been so long since I've been kind of looking at these, but DCJS is another really cool one. Tau charge. This is the one I was thinking. Oh, yeah, it's like the project's almost not maintained. Okay, so they're just hosting it from GitHub pages. It doesn't have the right SSL certificate. Well, in any case, here we go. I mean, on everything, the site looks beautiful. The examples, they're interactive. And essentially, you create a chart. They just have this generic overarching, like, single class called chart. You tell it what the data is, what type of chart you want to render, what the X and Y properties would be for each data option. So you don't, mapping over data might not be too difficult for a developer, but really declarative, data-oriented plotting is the pinnacle we can achieve for a top-level developer experience. It makes your code so much more clear. And again, they're just specifying what the categorical value should be. That'll color it. For example, if I want to say color it by genre, then boom, it just figures out all the genres and figures out a good color mapping for that. Like, this is seriously an excellent website, excellent project. The only reason I'm not like jumping on it, well, I think it's got one main developer. Let's see, how do you see contributors? I mean, it said 26 contributors, but that doesn't tell the whole story. Firstly, this is like a concerning thing, and this has happened in many, many JavaScript projects, in particular in many, many JavaScript charting projects. And if you're building a product around it, you don't want to see that. unless you're planning on maintaining this project. I'm sure, Marvin's done, I'm sure, like a lot of work here. You can see they've been involved with hundreds of thousands of lines that have changed. But I guess the core maintainer has stepped away, who knows, perhaps even from developing in general. Stuff like this I really have learned to take seriously when I'm evaluating a new kind of dependency in a project. In case nothing is perfect, but this tau charts or DAO charts, I don't know how I guess tau charts. It's so nice. It's really nice. And maybe it's just good enough. It's so well developed that it doesn't need a lot of continuing changes. So let's make it, so we want maybe, let's just say language. Yeah, something with fewer categories. So most of these are English. Oh yeah, another cool thing, you can filter. So people can start asking their own questions of the data. That's why it's so important that we provide interactive plots, interactive maps. It's not just like, I can anticipate all the questions people will need to ask. D3 is too low level. I mentioned that earlier. Do you mean that this might have a dependency on D3? I don't want to write my own plots. I want to work at like this level of abstraction. That's where I want to be at, not manipulating DOM or telling, changing the size of divs and things like that. I recognize that that's important. Somebody's got to do that. But I'm not a chart designer. I want to be a chart user in my web application. I want to focus on the business logic and what makes our application unique at this layer of abstraction, and not down here or even another layer lower. D3 even might be too low. It's basically like assembly language for plotting. All right, so we just need a function to calculate the color. And this is going to operate in a row. So what I'm going to do is apply this function to all the rows in the data frame. And so if row, what did we call it? Within food catchment. See, I don't even really honestly want to be having to write this kind of a function to choose a color. The library should just really handle that. It's just, I think, so important, because this is just something that slows people down. And it's not central to the concern. Granted, I'm not so super focused. I don't really know what I'm trying to achieve right now. But that's already a big enough challenge for me to face without having to wrangle with writing my own color mapping function equals, or if it's true, return. What do they say? I can just use this one would be green, blue. Otherwise return red. Boom. Yes. So we're going to choose color method, and what I'm going to do is just apply that to our data frame, our buildings data frame. And create a new column from it. See, all this is just extraneous stuff. And what if I want to change the color scheme? I should just be able to pass in a dictionary of colors, perhaps, or color schema. Like some of these higher level languages, you just, these libraries, actually I can give you an example here. You just tell it, like when I plotted this, I told it it was categorical, and that the column I'm categorizing that has the categorical variable is that, and that I want it to use this color map. So this is already a high-level example. The thing is, this is not interactive. So I can't zoom in or pan or get a tool, like a hover tool, any of that stuff. So trade-offs, I know nothing's perfect. But there's some libraries that come pretty dang close. So I'm going to apply this function now to create a new column on the whole data frame. That's pretty quick. I mean, it's just scan over. Well, not many rows though, I suppose. Well, wait a minute. No, I did it on the whole data set, didn't I? Yes, now we've got this color column. Right, there we go. There we go. So I'm just using the CSS color names. And I'll get a tooltip in a minute. Color equals color. That's all. When I plot this circle there. So this is data oriented, right? I can say that the column is the color is contained in the color column, but it would be really nice if maybe it can, and I just don't know how. But if bokeh could kind of, if I could just tell bokeh was a categorical column, something a higher level, keyword repeated, oops. And show. Let's see what's going on here. Let me save this. We should be. Ah, okay. I didn't let it through. That's the problem. It's actually not in our data source. It's failing silently, which is not a good thing to happen. There we go. All right. So now we've got color coded circles with a grayscale base map. Looking good. Now, one thing this is doing that's nice is it's automatically scaling it to the extent of the data. That's pretty fun. I don't think in this case we really need the tooltips, but since I've got it working on a small subset of the data, I can just take that constraint off now, I think. Yikes. Yeah. All right, so that is another challenge that if I zoom in, what happens? So let me zoom out. The plots aren't scale dependent. The points aren't scale dependent. Which kind of makes sense. Given that Plotly is not really a spatial plotting library. And again, this is just so I can see it in the notebook. I will have to just kind of call it good at some point. Here we go, that's a little bit better. Wait, Kesty. Oh, I see, both of those are active. How do I reset? I mean, honestly, it's not really that much better than that. This is how we learn. This is how we learn about plotting libraries that are available to us. It would kind of be nice if Bokeh just made these tools available by default through middle click, for example. And scroll, like maybe it was that these were automatically enabled or that there's a configuration option to make both of these active. But this one, this box zoom should kind of, it's not a geospatial plotting library, and it shows. But it does have this cool thing where you can save it to a JPEG, or a PNG file that is. Open that up. And there you go, you can share it with somebody. All right. So, yeah. Well, I thought I would have a quick stopping point, getting a bokeh map on there, but it took another hour. What time is it? It's only 9 o'clock. Let me just get a drink real quick, and then maybe I'll clear my mind and see if there's something else we could try. Cool. All right, it's Friday night. What better night to do some coding, some live coding. And I have a treat. Club mate. Pretty tasty. All right, so let's not, I realized that this whole last 2 hours have been pretty much a big digression. Let's just call it that. I'll commit this bokeh thing. If anything, this has solidified my understanding that I'm not really going to be able to rely on Python, more or less, to prepare or present the interactive map. I kind of knew that. Again, I was just wanting an interactive map in the browser, in the notebook, so I could sort of myself get a better understanding of the data as I'm working with it. So I think bokeh is going to support that need just fine. I just have to remember to keep those checked. So what is important now? In a way with bokeh, I might have stepped back because I'm not sure how to render these plots, but I can, because I need multiple layers. Okay, so let's go ahead and let's do another part of the analysis. We're going to do some set operations on two different data sources. Buffers, so some geometrical buffers around points, and then finding the intersection of those. So we're going to work with the bus stops. $700 bus stops. $55 food sources and 16,000 buildings. Set that. That doesn't work. Let's see what the bus stops structure is like. Maybe we've already done that. I already did that step. That's it. Gotcha. Running things in out of order and then trying to run the same cell again. Okay. Let's just commit this. Now basically we want to just buffer those. And for this part I might split it out. Food sources. And let me just double check. This helps me to make a table of contents and keep track of what's going on. So I can scroll around. It would be nice if it indented it a little bit. All right, for the bus stops, we don't want 1 full kilometer generic. But the problem is it's going to be same thing. And for bus stops, I think like 500 meters would be a more reasonable buffer for proximity analysis. All right, now similarly with dissolving, we want to mark down so. That's fine. Let's mark down so. Mark down so. Boom. Bus stops coming after it. Huh, wonder why it's got so much. All right. Domper's got really good public transport coverage, I'll admit that. What we're going to try to do now is find the intersection of those two. And then we'll call that something other catchment, and then find buildings within that. So let's go ahead and name this. So both these are multi-polygons, meaning we should be able to do a geometric operation on both, one against the other. Which is essentially a set operation, which we're doing. So I might even be able to just figure this out. Now by guessing so much as reading the inline documentation. So let's see. I believe intersection is the right one because we wanted it where it's both, with the points on the map where it has membership in both. So that's the intersection. So if we just take one of the catchments and take a look at the methods available. Another thing, these convex holes, this is what I've been thinking about also. Getting the convex hole for the for each of these classes, the purple and blue or violet or whatever classes, but the problem is a convex hole of just say like these lighter purple ones or whatever, violet. What would we call this? Plum and violet? I don't know. But the convex hole would be like all the way around, more or less, you know, like that. And what I'm really thinking of, and this might not be useful, but would be to find clusters. There's got to be a different way to describe this. What I'm really looking at is how to do it. Get a tessellating. I think tessellating, it's like, let's What's the name of that? Essentially, these geometries, for each of them, where they have natural boundaries for each group and preserves the class of the group. There's a type of geometry that describes this. I'll think of it later. It's a type of a map. Here it is. Voronoi diagram. Yeah, I was not going to remember that. So I essentially want a Voronoi diagram with two classes. I want each of these cells to be surrounded by a class. It's a Voronoi cell. What the heck, man? You can tell I'm getting tired. Maybe it's too late. But each of these classes, each cluster would be surrounded by a Voronoi cell. And I would have an attribute of the class. That might be possible. I'll have to look up. It's essentially, in a way, a clustering algorithm. Something would have to know the boundaries to draw. That's a good example. I suppose this would be an example. Is there a boundary between these? There doesn't seem to be one. You could make a... You draw a line between those. Sci-fi has it. I'm not sure if this is aware of a classification. I'm getting ahead of myself. But it should take into account the class decision boundary as well. We're kind of after. It's like a kind of a machine learning method, isn't it? And again, they're using clustering here. So I could, probably at that point I would introduce something like a scikit-learn. Interesting. All right, food for thought, food for thought. I want to do something with this. It's already pretty useful visually. It's visually intuitive, especially with the base map. You can just see the problem areas. That's why I was adding this base map earlier. Five was too big, 2 is kind of too small. I mean, it depends on your zoom level, I suppose. So you got the same effect. Okay, so got these catchments. Now we're going to look, though, I got another aside. We're going to look for intersection. There it is. There's a couple of them. So the intersection is what we're after. Intersects would be returning a Boolean whether these two do in fact intersect. Of the food sources. a lot smaller than I was expecting. Oh, well, 'cause there's not so many food sources. We got a 1 kilometer buffer around those stuff. All right, now I wonder if I can just put this geometry on the map. I'll need to convert it to GeoJSON. Boy, that's a lot smaller than I was thinking. But again, the scale is difficult to see without a base map. I think this is most of the downtown area and some clusters, and pretty much, if I refer back to the original project, it's loading up on the wrong screen. At least the splash was. At the end of the day, the union of the two, did I preserve that? So I got the buffers. I didn't keep the union because it's a computed field. The union is essentially these building footprints. So we might be in a similar shape where much of the downtown area is in both, but I didn't ever see the actual union. Because what I did is when I checked the set membership for each building footprint being inside of first the food sources with 1 kilometer buffer, then so I added an attribute there on building footprints. And so I did food access first, then bus access. And then I did a computed field twice by accident, whether or not it has both of those. So the ones where either of these is falsy, it's false. So if it's an and, basically. And that's essentially a set operation. Intersection. The cool thing about the set operation is then it allows arbitrarily many sets, I believe would be at least one at a time. Okay, cool. I'm getting tired, but now we're making progress. So I've got the catchment. Now this is just a geometry layer, so it's not going to have this plot method. It's a series, but I might be able to put it on top of this. On the base map, at least. I'm not a big fan of this toner. Now that I look at it a little bit more, let's just do OSM. I like the grayscale, but something about it. What I want to do, instead of having these dots on here, it would be nice to have layers you could toggle on and off, but okay. I lost that ability when I got rid of leaflet. Instead of buildings JSON. I don't have to change the coordinate system, that's good. Yeah, instead of the food sources catchment, it was called One second. So I'm going to just, for consistency's sake, rename that. Then I have to take this multi-polygon and convert it to a pandas geoseries, which has a toJSON method, unless the multi-polygon does not have a toJSON method. So unless there's something else, JSON, there's not. I looked this up before. I'll just check again. It doesn't hurt. Shapely multi-polygon to GeoJSON. Somebody else has looked this up before. I've been here before. And this is the exact answer. They just said use geopandas. All right, that's actually not too bad. I don't know. Those are all, every one of them is a bit awkward, so let's just stick with this one. Yeah. All right, so basically we take this multi-polygon, convert it to a pandas geo data frame, which you have to use the geoseries method to do that. Because it's a multi-polygon in a single row of a series, I guess, toJSON, we get the output. Then don't need to color code it necessarily. Oh, and just need to go back. Run through all these, I think. Something. I've imported the data, but I haven't run that color mapping function, which is just another example why it would be nice if the library abstracted that from me. It's just less error prone, less verbose, or yeah, more direct to the point. In other words, it documents itself, but okay, category tree. Like this one documents itself what column I'm using for the category, but here's where I need to actually run that. So there we go. So we know that that's that. This time I'm just going to use this access to amenities. Actually, I can overlay it. That's right, because you get the plot, and you can put multiple elements on the plot. Again, it's failing silently, but that's why, isn't it? Probably also takes different arguments. Oh, no. I'm not reading this close enough, am I? I can't plot a circle on this. So first let me reset the plot. I need to add polygon. Polygon. So we'll add a tile there, we do want that, but we don't want to plot the circle right now. We want to add a multi-polygons. All right, so I believe the multi-polygons should take our geosource. Has to be converted to a geosource. So hoops to jump through, hoops to jump through. What else did we take? Whoops. Let's just check the arguments without too much guessing. And since it's not a spatial plotting library, then it doesn't have any kind of awareness of necessarily of GeoJSON, I suppose. And things like that, which is why we need this GeoJSON data source. But it would be nice if this GeoJSON data source would provide it in the right format. Maybe it does. All right, so we got circles there. Well, I keep having to remind myself, the goal here isn't to plot. I've already actually plotted it, so let me just revert this. I plotted it without a base map, which is okay. All right. The goal here is to add another attribute to the table. And not get too bogged down with the plotting steps. Okay, so for each building, essentially, we want to check that centroid is within the, not only now within the food catchment, but actually just against the access to amenities. That's the key. So we'll add another column. And I think this is using the centroids because it's a multi-polygon geometry column. So it'll be a little bit slower. It's going to take a while. It's going to take at least twice as long because now we have two operations. And I should probably run these in separate cells just so I can compare the calculation. It's a smaller, it's a more geometries though. I don't know if that makes any difference in the calculation of the timing of the calculation, the processing time involved. But one of the main takeaways is this isn't something you could expect somebody to tweak the parameters at runtime and make a request to a server and have the server return the result. This stuff has to be pre-computed. All right, it took 35 seconds. Yeah, and I think adding the access to amenities was the slower one, but I feel like more than tripled it. Let's time them both. So once this one finishes running, and the other one will run. Cool. So yeah, I'll just post this. All of our source code is on GitHub, as you can see below the video, and we've got a bunch of parts converging. Right now, we've got a Python server project written in Django and Wagtail CMS, and it's going to be the main, I think, basis of the platform. We have a JavaScript client that's going to be the main mapping and exploratory analytical interface. And then we've got these Jupyter notebooks. And these are just where we're right now experimenting with the kind of geoprocessing pipelines to get the data ready. So right now we're doing proximity analysis to various amenities. So that all of our changes prior to this live stream are in this pull request here, and I'll push the changes up shortly that we're working on here. Once I get to a good stopping point, I'm pretty close right now. It's 3.5 hours, and learned a bit. It's pretty nice having some good club mate. I'm not sponsored or endorsed in any way, but okay. So basically, they're pretty close, 15 and 20 seconds. It went from 9 seconds to 15 seconds because now I'm comparing this whole multi-polygon instead of the points. Now, where did I lose that? Mapping. Let's make it a little faster right here where I switch the geometry column. I've got this, let me just make sure. Building centroid column is there. Because then we're going to move this centroid over to the geometry column, and we're going to rename the geometry footprint. Yeah, and we've got, so this is all running in different order. So previous cells have, subsequent cells have been executed, and the data frame still has their output. Yeah, so actually I should remember that. All right, so basically what I'm trying to do is, now if I run these, it's going to be a little bit faster. Going from 15 seconds to probably around 9. Because instead of comparing each row's polygon with the polygon, it's going to compare each row's point with the polygon. The centroid is the point here. The footprint was a multi-polygon, which makes it inherently a slower operation. It still took as much time in any case, all right, whatever. We've got access to amenities. Remember, so now I can just plot those. And this should be a bunch of points now. Okay, this is pretty cool now. This would be good to compare side by side. So the same colors, but if we plot within the food catchment, it's a bigger area. And then if we add another plot down below with access to amenities. It's almost it's the exact same, so something's gone wrong in my code. Let me check out why. Because these shapes are definitely different. Let me think here. I think that what's going on here is that the bus coverage is so good that the access to amenities is essentially taking on the same shape exactly as the food sources. The difference is so small that you can't really tell from here. Okay, this is where tweaking the parameters comes in handy. This is where it's going to sort of more than likely lend itself to real-time analysis. We're going to have to figure out a different way. Now, are there no notebook, we had, instead of 500 meters to the bus stop, we went down to 250 meters. Food sources. And it chips away at it a little bit. Now for plotting purposes, I think just plotting this overlaid on a base map would be good enough for an urban designer. The reason we would calculate these, so that's actually a relatively fast operation. That could be done at query time, more or less, to tweak the parameters. Send that back to the client. All right. These buffering operations. They take almost no time, even with, wait a minute. Here's the actual buffer operation. The buffering operation is so fast. I could include the dissolve in there, but it's essentially, it's just almost unnoticeably fast. And the bus, there are, how many bus stops? What was the shape on that? 700. Yeah, so this kind of stuff could be amenable to real-time processing, even tweaking the parameters in a browser with something like turf.js. Might be feasible to do these buffering in the client. Once you've got the parameters, once you know the buffer distances you want to apply, send a request to the server, allowing it to bake that into a table or something like that. I think that's going to be a direction this project will take. That's the whole reason we're here, experimenting and taking our time and making mistakes, is just to figure things out and to try things and get a good direction and not be too set on things being one particular way, but learn. All right, so this is cool. I've been wanting to use turf and make our client more rich and interactive. So yeah, then what we would do still on the server side would be to take those, we'll still have this same code more or less they would either make a request, and probably this is better, they would make a request with the calculated buffers from turf, so that there's no mistaking what they saw on the screen, because turf buffers might differ from geopandas buffers in a subtle but meaningful way. So in any case, this can probably be serialized, sent over the wire. Yeah, oh, yeah, number of steps is here. Number of steps is also a parameter in the geopandas buffering. Yeah, there's similar APIs. They call them resolution. In any case, I think we would serialize this. We can maybe even do the union. And dissolving it. Geez, this is very powerful. So yeah, I think tomorrow we're going to be coming back to this, doing some live coding. I'll work more on the JavaScript. I want to get this Python in a good stopping point. And yeah, we'll be adding turf.js tomorrow, figuring out some way of creating an interface, serving up these points. The points will come from the server, points will come from OpenStreetMap data, the bus stops, the food sources. They'll come from our Django server, more or less. And then giving the client some interactive some user interface elements to basically allow you to do this analysis, but not having to think so much in terms of unions and things like that, but rather asking a meaningful question: how far will people walk to get to groceries? And then implementing the buffering union in JavaScript. And figuring out then how to make the request to the server, what to do with it in Python is basically more or less sussed out. We just won't have to do the buffering. We will do the point and polygon queries. So kind of this stuff here. Buildings within. Yeah, I think this is probably, because one, we probably don't want to ship 16,000 points to the browser. That was a lesson we learned so far. But because this is not rendering with Canvas, or is it? Oh, wait, it could be rendered with Canvas, actually. In which case, then 16,000 is a low threshold. It's a matter of, yeah, the server should do some of the heavy lifting, that's for sure. Because not only is it a matter of the DOM and rendering and things like that, but the slowness came with the processing of the data, doing the geo within. If that's even a possibility with turf, it is, but it seems like we wouldn't have the nice API. We would just map over them now. Think about it, we'll cross that bridge when it comes, but so for each of those 16,000 houses we would do a geo within. The buffering, that's a no-brainer. That will be something we could do in the client. And then we can probably benchmark the server and client code. I want this to run on a tablet, so that's a constraint. All right, good stuff, good stuff. So now our catchment's a little smaller, right? Smaller. Let's commit and push and call it a night. Oh boy, we're almost at 4 hours. Those hours, they go by really fast. It's crazy. But I'm glad I went into this third hour, because I had been thinking about TurfJS, but now I know concretely what I would use it for. Maybe it's Friday night, I can stay up a little bit late. It's not even that late. All right. Yeah, so essentially an operation that takes this long, 14 seconds, is going to time out on the client, so we'll have to just think about that. It would be something like, it would be an operation where the person knows they're going to have to wait for the result. And perhaps we could use something like Django channels to signal when the result comes back, so they don't have to refresh the page. This is still running. Yeah. Which sort of is leading into the idea, for this project, it's open source. All the data we want to be open. We want to honor the OpenStreetMap license. I want to contribute to the general open source ecosystem, in particular the FOSS4G, so free and open source software for geospatial applications. But in order to focus on this full time, I can't do this on weekends. I'm going to have to come up with a business model. We actually have, to be fully transparent, we've got 2 roadmaps. We've got a business roadmap and a project roadmap. So if we look at the project roadmap and the business roadmap briefly, just so people see while we're on this topic. So we're going to figure out if there's a way we can sustain this financially. I don't know what it'll look like. I'll circle back around with why I brought that up in just a second. And then we've got the project roadmap, which I'm kind of a little bit straying from. More or less, we've got this progress, but and the food amenities. So I'm not too far off track. This is going to go back because I hadn't had a progress update. And John's reading Django for beginners because that's our server infrastructure. Now the business development, we need a business plan. We're working on that, and we need a way to generate revenue while operating in integrity with open source and open data values and ethos. So what I'm getting at is I think it might be an opportunity. Our main users are potentially urban designers, urban planners who need to have an analytical framework that fits their way of thinking and not so much makes them drop down to different lower levels of abstraction, like thinking in terms of geometries or even set theory, data types, you name it, mapping functions, all that kind of stuff that you have to kind of encounter when you're working with typical GIS tools or programming tools. So that said, if somebody's running an analysis and they've got their data, and one of the things that we would be fair to charge for is the usage of computing resources and storage. So not only just in terms of getting by, but as in terms of maybe that's a value we're legitimately providing and could be an element in a business model. So kind of what's coalescing in my mind a little bit is it might be worth thinking about. So if somebody's, through the client, designed an analysis by buffering certain amenities, fully interactive, it's targeted at a goal they're trying to achieve or an environment they're trying to improve or whatever their particular work is. We don't want to be too presumptive about it. They send that to the server for geoprocessing, and we store the result, they operate on the result, they export it, whatever they do. That's a fair, I think, business transaction. The data is should be, to the extent possible, open. That's going to be a challenge. We'll have to kind of navigate the licensing in terms of the OpenStreetMap and the fact that we would like to also have, in some way, contribute to improving the quality of data, because the quality of the data is going to affect the quality of the analysis and the output. We don't want to be a walled garden. Cool. So that's a long way along the side. Now let's see. So that's within the food catchment. Let's see if these are any different. And this is where like a visual diffing algorithm would be handy, but here you go. Now we can see much more. When I change the buffer, the radius for reasonable walking distance to a transport hub or transport stop to 250 meters, and then did a union of that catchment with the food catchment. Here's the result. This is a lot better. So it targets places that could be needing a transport intervention. Most likely, I guess. So yeah, if I'm just looking at the food, then all I would need is this. The thing is, livability is not just about food and transportation. So you start to add layers into this analysis, and that's what we're trying to make it easy to do. So you could select from up like 5 or 10 different amenities, tweak the parameters to your need, submit the job for processing on the server, because if you're doing this on a tablet, on a train or whatever, you're not going to have a lot of computing resources there, but that's where the server is more powerful. This can be run on your own server. It's not relegated to any one particular deployment. But yeah, things are starting to come together a little bit. Yeah, and some other things that you could do then, not only visually see it, but you could get statistics back. Like how many, you can count the numbers of truths and falses. So let's see, how do we do this? Well, I think it's just kind of a straightforward one, if I recall correctly. The reason pandas. So just by way of reference, we have 16,000 buildings. And if I just want the ones where, let me think here for just a second. Since you're going to make a mask, let's make this code a little bit easier to understand. Well, heck, it's already going to be pretty straightforward. So I just say access to amenities equals true. I think this should work right here. Right, so I'm just going to subset it, but I'll just grab the shape. I got to put that in square braces too. Right, how do I do this? Heck, I got to refresh my pandas knowledge. So you do a mask, then you subset it. Oh, yeah. Okay, I got it. First you create the mask. There should be a way to just count these. Then use the mask to subset. Man. Actually, I just want to count. There's val counts. That's really all I'm after. I'm surprised I can't remember how to do this. Jeez, I've been only off work for like 3 weeks now. All right, val counts, something like that. Man, what is buildings? Yeah. Dot tab v value counts. Just trying to be lazy. And I need to specify the column. There we go. I'm almost there. Building. I don't know what I did wrong here, but in any case, here we go. Yeah, so this would be indicative of a problem. 14,000 buildings don't have the defined access to the amenities we're after. So that's a useful metric, and something you could track over time too. Like organizations are increasingly important about key performance indicators, and what are those things called? The like OKIs or whatever, the stuff like tracking progress towards a goal. Yeah, and sustainability is a noble goal. How we quantify it and how we compute, like how we convert sometimes qualitative data like convenience to numerical values like 500 meters. Yeah, that's the tricky part. We'll have to figure out slowly, but yeah. They can track this over time. So on the client, we'll need a general purpose plotting library anyway. We need a solid mapping library. We're going to focus the project right now on two-dimensional data and step back from the three-dimensional data just to keep things from getting too out of hand. And even in this project, I think I'm going to just get rid of the bokeh. Because really this rendering has been insightful enough. Yeah. So. And if that's the case, just really quick, we do need a geometry column for this. I was just seeing if I needed to do that renaming, but the buildings within is going to look for a geometry column. All right. Let's see if we can do a proportion. So that gives us a 1 to 0 scale. Huh. This is so good. When things just work like that, that's so nice. So what it's saying is 90% of the buildings in Tampere don't meet my arbitrary definition of access to amenities. The cool thing is the urban planners can define their own thresholds and their own metrics. And all we need to do is just present them with the right data coming from OpenStreetMap, and I hope that'll actually incentivize more government, like municipalities and governments, to contribute to OpenStreetMap to make that quality good, to bring that quality up, so their analysis will be good by extension. Cool dudes and dudettes, peoples. We're gonna have to call it a night, but yeah, so 90% don't meet my definition of good, and about 10%. Dude, we would need zoning data to say, you know, it's more important that you have residences that meet these criteria than businesses, so that would change the output. All right, cool, let's commit. This is a pretty big commit. I got rid of bokeh, but and it's not diffing it for me. Or it is, it's just really slow. Let's just say, well, how do I summarize this? Initial composite analysis. And just for reference, let me grab a book real quick. All right, so before I conclude, or actually, I'll do this. In summary, it's been kind of a long session, thrashed about a little bit, that happens. Key realizations, I don't need to focus on web mapping from a Jupyter notebook. It's not really the goal here. The goal is to sort of visualize data occasionally, so I do need a map. And an interactive map is nice, but not critical. The web mapping will be left to the client. We'll come back to the client tomorrow. So today I've kind of simplified the map, the notebook. I tried bokeh, and I've removed both bokeh and folium. Folium got bogged down with the amount of data we were putting at it. I think if we're going to send this much data to the client, it's going to be, we're probably going to need to render it in a canvas layer instead of a DOM layer, like SVG layer. I believe D3 still supports that, so we might be able to use something built on top of D3. Another thing, a takeaway, I generally would like to use a data-oriented plotting library. More on that later, but if you've ever used Seaborn or Tau.js, Tau charts, I guess, and I think, for example, anyway, those are data-oriented plotting libraries. There's another one I can't think of the name of in Python. It even has a light version of it, something light. But in any case, let's move on. It's been a long session. I'm getting kind of tired. What we've done is taken essentially two different amenities, food sources and bus stops, and we wanted to see what buildings are within a convenient distance of those. Where previously we had done just food sources, now we want to look for buildings that are both within convenient distance of food source and a bus stop. So this is, I guess, a composite analysis. I'm using this book as a reference. It's called Urban Analytics. It's a pretty brief book, but it's interesting. And it calls it a composite index. So I think that's kind of what we're doing. We're essentially creating two indices where we have one that's saying that this is within walking distance of a food source, and then this building is within walking distance of a bus stop. And we can then use those composite indices to make to ask more elaborate questions. And it's like essentially set theoretical. So let's just take a look. We have in our clipped data set, just around the city of Tampere, we have 55 food sources. Those are basically convenience stores and supermarkets, I believe it was called. Copyright emptor convenience stores aren't necessarily food sources, but I don't know how to really separate out classes of subclasses of the convenience stores. I'm just relegated to the OpenStreetMap data. There's almost 800 bus stops just in the same sample area, and there's 16,000 building geometries. And that's all I know is they're buildings. There's a few attributes we can use, like if it's a retail, we might dig more into that, but for now, we're only looking at buildings as entities and finding out if they're within convenient distance of amenities. So one way that I believe, I haven't benchmarked this, but the idea is that rather than looking for a building footprint within a bigger, complicated geometry, that looking for a building centroid would be faster. Makes sense to me. So, and I think some libraries, they'll only let you look for point and polygon and not polygon and polygon. You'd have to look at overlap or intersection, things like that. So yeah, we just get the building centroids here. And this is not all new, but it's a bit new. And then just renamed the columns. Now, the reason for this is I want to treat the building centroid as the first class citizen there, the primary geometry for these objects, so that when we're doing the later steps, it will look first to the centroids, and while at the same time keeping the building footprint around. So we just did a little swap-a-rooney there. So now things are good, and you can see these other properties bleeding through. We'll show you how we got those in a second, and just check the data types. We have two geometry columns here, a geometry column and a footprint geometry column. This kind of gets important when we were exporting a GeoJSON, but by removing the kind of idea in this notebook, at least, of web mapping, it's simplified things quite a lot, and there was just some weird errors, not really worth going into right now. So for food sources, arbitrary convenience distance would be 1 kilometer. I think I'll walk maybe a kilometer to and from the grocery store to get a couple of bags or a backpack or something. So yeah, all we do is just take those food sources and we add that buffer around them. And it returns a geoseries, which is essentially a single row multi-polygon. This is a typo. There we go. Oh, what did I do here? Now for bus stops, honestly, Tampere has such good bus coverage that if I did a 1 kilometer or even 500 meter radius to bus stops, it's like covering the whole city. So the composite index or composite analysis wasn't very meaningful. Again, I could drop this one down to 500 meters, something like that. I don't know. The exciting thing is we're going to let the client, the end user, decide all these things, and I'll get to that in a minute. But essentially what we did is just these buffers create a bunch of circles, circle around every point, and we just dissolve those into, I showed this yesterday, but we're repeating it today, so it wasn't too hard to figure things out. We'd already done that into a multi-geometry by taking the union of those. You can see I hadn't really plotted the bus stops before. I can do that just by way of example. Another thing I've figured out during the stream is that these buffering operations are pretty quick. The operation, and they can even be done in the client. I mentioned that a second ago, but one second, let me just, without taking too much more time on the stream. All right, so it's basically the same thing. This is just plotting points with a line thickness that essentially is like comes out similar to the buffer. All right, same shape, but when we took the union of it, it gives us this shape. I'm not going to do too much more live coding on this. I've done 4 hours now of the live coding. And the key thing is we want to take both of these and find their overlap, the places that have access to both amenities. And it comes out, very similar to almost all of the food source buffers have ready, transport access. But it's just different enough that we can do a meaningful thing. Now here's what takes a while, is then for each of those buildings, 16,000 buildings in the just a selection in Tampere, we're going to check the building centroid against this geometry. So it takes under 20 seconds though. This one took a little bit longer because the food sources catchment maybe is simpler, I think is the deal here, whereas the access to amenities kind of polygon is much more complicated and it might not have been dissolved properly. I'll have to take a look at this because I see some overlap in these points. I think it's just because of the line styling and not actually the fact that they weren't dissolved correctly. So that took under a minute though. And the key thing is we'll just have to indicate to the end user this is a process that's going to take some time depending on the sample sizes and the complexity of the buffer geometry. So it'll be something, they'll be able to design the analysis in the client, they'll submit it to a server, and then somehow be notified on completion, hopefully just in, not necessarily, well somehow it'll be a push notification. We haven't gotten to that level yet. But that's it. So then what we have is actually kind of interesting. Now, just this can be overlaid on a base map, and then you can see at a glance areas you might want to have a design intervention. That's useful and meaningful. But then when we actually materialize it, so to speak, we actually run it against all those buildings. You can see which buildings specifically meet the criteria, the type of building, other things. So you could even do further analysis on top of this. So you could say, show it's only retail buildings that don't or do or don't meet this criteria, or hopefully residential. I'll have to look more into the typing, the type properties. And here they are plotted. So here's the within food catchment, which is where we left off yesterday. Here's in the access to amenities. So you can sort of see the difference there. It's not a huge difference. I had to tweak some of the parameters, but you can see some more actionable area here perhaps. And here there's a lot more distance. Again, with a base map, this would be a lot more meaningful. But that was the key thing, is just to figure out if this is even feasible or meaningful. And the final thing we did here is just came back, took a look at the data, and we just checked the proportion of those values that have access to amenities, the proportion of buildings. And based on my definition of access to amenities, which is arbitrary, 90% of the buildings in the subset of Tampere didn't meet that criteria. And you can kind of see it here, but we can actually quantify it. And the important thing about this is not only can you get a statistical measure you could take to a meeting and show them visually as well as more analytically, but you can track this over time. You can set a goal and measure against it. If you repeat that analysis, there's a lot of things you would need to probably make sure the data, well, hopefully the data quality will only improve, and hopefully this is also would give an incentive for municipalities to contribute to OpenStreetMap, because that's the primary source of data here. We'll be cloning or mirroring the OpenStreetMap data and making some derived tables, but in essence, we're going to treat the OpenStreetMap as our immutable initial source of truth, and add some value to that, which will also be openly licensed under the same database terms, from what I can tell, depending on how the definition of facts falls out. And the main value we're adding, though, is the analytical framework. So we want this project to be open source. We want it to support the open data and open source ethos in ecosystem. We've got to figure out what value we're adding as a project and potentially as a business, because we're trying to also form a business around there and be transparent about those efforts. So I mentioned that some of this was going to happen in the client side, and another great open source project which we have not had a chance to work with is Turf.js. It has a buffer method, and given that buffering these relatively small samples of data, like the number of convenience stores is under 100, and the number of bus stops was not that high either. It's feasible to do this in a client, even like a tablet. So we had almost 800 clients, and we had 55 food sources in a subset of Tampere. Might not want to do this on the whole country or a whole state with huge cities like New York or California, but we can do some of these operations in the client. The important thing about that is the closer to real-time feedback you can give people, the better. We're used to directly manipulating objects, pushing a bottle on a table, or and getting some kind of like feedback that something happened. So the tighter you can make that loop, the more intuitive and user-friendly the tool is. So if we can allow people to, in meaningful terms, tweak the buffer radius, not have to think of it as a buffer, but like a walking distance, that would be powerful. We can serialize this, the output of that operation, and it even has a not only the buffer, but it can do it can dissolve the buffers too. Here it is, and it can do things like finding intersection of different geometries as well. So we're gonna tomorrow start working on the Turf.js integration. So we're gonna swing back over to the experimental client UI. So far, so here's our, for what it's worth, our sustainable urban design roadmap for business development. We're really trying to be fully transparent while acknowledging that not only do we want the project to be open source, we want it to be, so we want to have a sustainable community around the project. We want to be financially sustainable. And so if you go by our organization, you can check our business development roadmap. If you go by our source code repository, you can check out our software roadmap. And what I was going to point out here is we have this pull request in progress, which I'll probably have merged by tomorrow. So you can see the kind of stages this analysis has gone through, the proximity analysis notebook, as well as our JavaScript user interface experiment. We haven't merged this in with the main project yet. We'll be swinging back over to this tomorrow, probably integrating turf.js. But basically right now we're building on a project called Quasar and Vue.js. We have Mapbox.jl, a GL for rendering the geospatial data. We're gonna originally we're considering rendering three-dimensional data and getting kind of fancy, but I'm gonna go back to just thinking in 2 dimensions. That's mostly what OpenStreetMap data is. It's 2.5 dimensional data. It's got some heights that we might end up extruding at some point. But to keep things simple, we'll just go with 2 dimensions, integrate turf.js, try to start working with some buffering and maybe intersections, but I believe that when it comes time to compute these intersections, the more computationally intensive part, it'll be best to do that on the server, where there's a guarantee of a certain amount of computing resources to be available to a certain extent, whereas end user devices vary widely on that, if they're on a tablet or a desktop with ample resources. So that's where we're at. It's been a long session, but it was, I think, worth it, just in terms of exploring, failing, succeeding, and having a deeper insight into where this project might be going. So I appreciate your time. It was nice everybody stopped by the Twitch chat. It's always nice to have company. If you're watching this on YouTube, do feel free to ask any questions. If you want to get involved with this project or others, stop by codebuddies.org. CodeBuddies is a really excellent community. Everybody there is both a teacher and a learner. The CodeBuddies platform is also open source on GitHub. So if you're interested in learning how to do open source development, you can get involved with either of these projects. We're very open to contributors of all types. You don't have to be a coder. In fact, you can be a designer or somebody who's interested in just the idea of sustainable urban development. You're welcome to stop by and share your ideas, give us feedback. All right, well, thanks for your time and have a great day. I hope you're staying well out there.